Hello everyone. I want to start with the question. Does it make any difference whether you have $1 million or whether you owe someone $1 million? Having $1 million is having a positive $1 million. Owing $1 million could be thought of as having a negative $1 million. Does that make any difference? Well, yeah, that makes a difference. But sometimes the sign of a number really doesn't matter. All that really matters is how large is the number, what is its magnitude, how far from zero is the number. Sometimes that's all that matters. Often, if the number represents a distance, we may not really care about the direction. We may just care about the distance, and in that case, um, what we're talking about is the magnitude, and we call that absolute value. So let's look at absolute values, and specifically we're going to be solving equations that have absolute value expressions in them. So quickly, what is absolute value? Absolute value is the magnitude of a number. Okay? The absolute value of 5 is written like this, with 5 inside these vertical bars. It represents how far a number is from 0 on the number line. We have the example, -3, of course, is to the left, 3 is to the right, but both are 3 units away. 1, 2, 3 units away. -3 and 3 are both 3 units from 0, so the absolute value of -3 is 3. And the absolute value of +3 is also 3. So the absolute value of a positive number is just the number, but the absolute value of a negative number is its opposite. And that's going to be positive. The absolute value of 0 is just 0. Quick examples, absolute value of 5 is 5. The absolute value of -2 is 2. Absolute value of 0 is 0. Absolute value of 2/3 is 2/3. Absolute value of -4/7 is 4/7. Okay, so I'll cover that up if you didn't see it yet. For the absolute value of 8, there are two values for x that make that true. Okay, so what are the values of x that would make that true? Well, x could be 8 or it could be -8, right? If x is 8, this is true. But if x is -8, the absolute value of -8 is 8. So the equation's still true. So let's look at solving some of these that have absolute value expressions. So the first one is the real simple one like we just looked at. Solve for x when the absolute value of x is 5. What are the possibilities for x? Well, x could be 5 or x could be -5. Okay, so let's look at some a little bit more involved. Here we have the absolute value of p/8 is 2. Okay, that tells us the thing in the bars. In this case, it's an expression. It's not just a variable, it's an expression. That expression within the bars could be 2. So we would write p/8 equals 2. But there's another possibility, right? What if the expression p/8 is -2? That would also make this equation true. And we got to solve both of these possibilities. So we'll have two answers, just as we had two answers on the top one, the simple one. So some of these we won't write every step. Multiply both sides by 8, and you get p equals 16. Multiply both sides here by 8, you get p equals -16. Two answers. Okay, let's look at the next one. Absolute value of 2n equals 2. Well, that means 2n could be 2, or 2n could also be -2. would make that true, right? We have to solve both of these. Divide both sides by 2. And then we'll finish solving this one. It says, oh, didn't divide both sides by 2. Sorry. Okay. N equals 1. Let's do the other one. 2n over 2 equals negative 2 over 2. We get n equals negative 1. Okay, 2 answers again. And about now you might be saying, aha, the first one we got a positive 16 and a negative 16. The second one we got a positive 1 and a negative 1. Looks like you could just do one of these sides, not do the other one, and just say, well, the negative. But it's not always like that, okay? Can't count on that. So let's look at this one. The thing in the bars, x plus 2. If it's 8, the equation's true, but that thing in the bars could also be negative 8. Okay, equation would still be true, so we solve both. We're going to subtract 2 from both sides. We'll do this one in our heads also. So we get x equals, and subtracting 2 from the other side gives us 6. Okay, over here, subtracting 2 from the left leaves just x. Subtracting 2 from the other side, it's negative 8. We're subtracting 2 from that, negative 10. And so we didn't do all the steps. We've done these before, though. You can do those steps on your own. If you want to write it out, check that that's really correct. But the main point of this lesson is seeing that you have to write the 2 equations and solve them both. And there will be 2 solutions. Okay. So we got a couple more. Okay. So do this in a straightforward manner just like the others. The absolute value of whatever this is equals 12 means the thing inside there could be 12, or that thing inside there, write it down exactly as it is, could be negative 12. Now I want to pause here. There's something that just trips everyone up. I remember this tripped me up when I first learned these. With these negatives inside, it just feels like you should change those to positive, but you shouldn't. Okay, that's just an expression. That expression might end up being negative 12. And if that's the case, the absolute value bars will turn it into 12 and make this true. That's what the absolute value bars are all about, if the expression ends up being negative 12. So that whole process is encapsulated in the fact that we made both equations. If this ends up being negative 12, our equation is true. And so we will solve that and find out what n would be in that case. And if this expression ends up being 12, then our equation is true. So either of those cases make it true, and we have to find the n for either case. But there's no reason to change the signs inside that. Okay? So we just say negative 2n minus 4 equals 12, and we want to find out what n would be. Let's add 4 to both sides. Again, we won't write down every step this time, When we add 4 to the left, it just leaves negative 2n. When we add 4 to the right, we get 16. Okay, over here, when we add 4 to the left, it just leaves the 2n. When we add 4 to the right, sometimes it pays to kind of scribble it out to the side here. Minus 12 plus 4. Even though we're kind of doing it in our head, we'll write that down. Looks like that's negative 8, right? Okay. So now we're going to divide both sides by negative 2. And we'll be careful. We'll go ahead and write this one out. Oh, wrote it down wrong. Negative 2n. We're going to divide both sides by negative 2. Okay. I just realized I've been doing this one step at a time back and forth. That might be more confusing. I won't do that anymore. Let's just carry this one all the way down. So we're left with an n over here equals negative 8. Okay. So now let's go back and do this one. Divide both sides by negative 2. Okay, and that's n equals positive 4. Okay, so you have to be careful on these. But those are our two solutions. Okay, one more. So the thing in the bars could be 83 or could be negative 83. Solve them both. Subtract 3 from both sides. Over here it's 10p. Over here it's 80. Then divide both sides by 10. P equals 8. Over here, subtract 3 from both sides. 10p equals, subtract 3 from negative 83. Scribble it over to the side to make sure we don't make a mistake. Negative 83 minus 3, negative 86, right? Okay, now divide both sides by 10. P equals, and you could punch this into a calculator, get negative 8.6. You could also reduce it to lowest terms. It's a little awkward here. Not too bad. You would, let's see, 2. 2 is the largest number that goes into both of those. So that would come out to P equals 43 over 5, negative 43 over 5. Okay. So I'm gonna, it looks kind of ugly. I'm gonna erase that. Just write those two possibilities. Okay, so yeah, for this is the same number, of course, but two different ways to write it. Negative 8.6, negative 43.5. So there are two answers, 8 and the other one, which could be written either way. So so that's it for those. You just write both equations and then solve them both.